Hi everybody, my name is Jill and my partner is Sujal, and we are the team behind Spark, a hands-on robotic learning kit designed to teach kids how to code without starting on a screen. We were inspired by mentoring elementary and middle school students during a STEM field trip. We saw how excited kids get when learning is physical and interactive, but also how quickly they lose interest when it becomes abstract, tedious, or screen heavy. Here's how it works. Each programming card contains an NFC tag. Kids arrange the cards in order to create a program. For example, move, forward, turn right, and repeat. We use an Arduino-based scanning pen to read the cards one by one. When the pen reaches the wrong card, the robot executes the entire sequence in the real world. This means kids can see cause and effect immediately. If the robot doesn't behave as expected, they can physically rearrange the cards and try again, just like debugging, but in a way that is intuitive and engaging for young learners. Alongside the physical kit, we build a companion website that supports learning for kids. This is the homepage. Here, parents, teachers, and students can learn about our mission. The homepage also gives a preview of future products and expansions, like additional robotic kits. Next is the challenge page, which is where most of the learning happens. Each challenge walks students through a goal, such as making the robot turn, follow a path, or even repeat a movement. The website visually shows what each block in the program represents and explains the logic step by step before the robot even moves. This helps kids understand why their program works, not just whether it works. The challenges are structured to gradually introduce new concepts, like sequencing and loops, while still encouraging trial and error learning with the physical blocks. Adults can see progress, understand learning goals, and explore how the system fits into classroom or at home learning. Finally, we also have a section where you will be able to connect your Arduino and see in real time what blocks are being scanned. While kits like Lego Robotics exist, many cost over $400 and rely heavily on screens. Our prototype cost about $100 to build, and with ESP32 and custom PCBs, we can reduce the cost even further. We plan to sell the kit for around $300, making it more affordable and accessible for families and schools. Looking ahead, we see this project growing into a full educational robotics platform. One of our next major steps is introducing modular robot component. This would allow students to physically swap parts like sensors, wheels, or attachments, helping them understand not just programming, but also how hardware systems work together. We also plan to expand the instructions block system. Future blocks could introduce new concepts like conditional logic, sensor-based actions, and more advanced movement, allowing the kit to grow with the student over time. We're also focused on improving scalability and cost by transitioning to ESP32 microcontrollers and custom PCB boards. Ultimately, our goal is to create an ecosystem where kids can start with simple physical programming and gradually grow into more advanced robotics and coding concepts, all within a single cohesive platform. Our goal is to make programming tangible, intuitive, and fun, and to turn this project into a scalable educational robotics startup. Thank you.